Good morning. So it's going to be very much on the nutrients and plankton side of the water quality with the COP that we've put together. So, small but active group. Mike and Elizabeth are in the room putting the slides in and the data together. So the difference between this bit and Ben's bit is Ben's been looking at the big picture, sort of using satellite oceanography and models of the North Sea for temperature. I've been looking at the data primarily from the Environment Agency, which is open source data that we can download. And that data is really, really good for data mining and looking for trends and so on. So it's mainly the coastal, near coastal EA data, which we've been looking at, particularly to try and find out what's happening, the bigger picture stuff underpinning the productivity of our East Mee area. So what have we got to work with? Well, good and bad. So the offshore area, this big area that goes right way out the Dogger Bank, we haven't got a lot of data out in that area. So that's something to that's something to think about. It's a huge area of the sea. We don't measure very much out there. The little red flags there, they're CFAS, the WaveNet buoy off the dowsing off the mouth of the Humber. That measures wave height and temperature. And the other red flag at the bottom, the two red flags at the bottom are the two remaining CFAS smart buoys from the Smart Buoy program, and they've got things like oxygen on them, and they get visited by ship actually, so there's a little bit more data at those two sites, but there's not very much in the northern part of the region. The three dots at the top are our Environment Agency funded zooplankton monitoring time series that we've put in place that Ben mentioned off Scarborough. And then the important ones, the red and green ones coming down, the red dots are the Environment Agency, where they do nutrients analysis and things like heavy metals, arsenic and lead and tin and PCBs and all of that kind of stuff. Full suite of water column pollution analysis. And the green squares are where there is some phytoplankton data. The big blue star is Elizabeth's plankton project, which fills in that huge gap coming around from the wash where there's no nutrient data. That's it's weekly sampling, isn't it? So you go every week to do your sampling on Chroma Pier, and she's going to be going home with a nutrient sampling kit to add to try and expand that out as a baseline. So to sift through the data, we've been looking for sites where the time series is longer than 10 years, so we can see what's happening, and also they've been visited more than, well, for salinity about 8 times a year, for nutrients a bit less than that. Now, outside of this room, the big process, marine monitoring in DEFRA World, UK Marine Strategy reports every 6 years. 2026 is one of the reporting year. So if you look on the Marine Strategy site, you'll see the bigger picture, so coming from DEFRA and OSPAR, of what's happening in our region. Very, very broad brush approach. So for phytoplankton, the yellow colours in our area indicate rising trend. This is one of the indicators, potentially rising phytoplankton biomass. I'm going to query that in a minute. And zooplankton, essentially not much happening or very, very low data. And you see low confidence in the results. So essentially there's not very much known for the pelagic habitat. So we'll stick with our inshore East Mee region with the data that we're quite sure about. Now this is quite serendipitous, so I've got the data for the River Trent feeding into the Humber, which is one of the main freshwater sources for our coast. And in that image from Michael from the RSPB, 80 kilometres up the Trent, probably in that photo is the river level gauge and water flow meter at North Markham, which is the last station on the Trent before it joins the Humber. So very, very good flow data going back a number of years. Look back to the 1970s, you've got really accurate measurement how much fresh water is coming in the system. So what we can see, the yellow lines for 2025, it was a very dry year. The drought started back end of February, and essentially we've got about 6 months of very, very low river flow, hardly any rainfall. The fields are turning brown everywhere through Lincolnshire and Yorkshire at the centre of that drought. And that results in 2025 being actually quite a low freshwater flow into the coastal system. So that's the first point. We've got less fresh water coming in than normal. How does that affect the salinity of the coastal water? which is, from a marine biology point of view, salinity is one of the factors. That might affect range expansion of things like crepidula and invasive species and so on. So we take the raw data, so it's the raw EA data where they go every month. This is the Hale Sands Fort site that we visit also from the University of Hull at the mouth of the Humber. It's like a really good sentinel site. That's all the ups and downs of the raw data, and then turning that into a yearly average, and to enable us to compare between stations along the coast, some high salinity, some low salinity, we take the anomaly, which is basically the annual average minus the long-term average divided by the standard deviation. And that's the anomaly plot, and the last dot on there, 2025, shows a positive anomaly. We've got a cluster of quite high salinity points. You've actually got a bounce back from 2024, which was a very wet year, up to 2025, very dry year. That actually shows up in the salinity data. So coming up to a higher salinity year, higher than average. And quite nicely, all of the 9 Environment Agency stations down the coast, so all the coastal stations, they're pretty much, apart from some years, there's a reasonable amount of synchrony in the anomalies. So they're not all doing their own thing. So that suggests, particularly at the end of the time series, there's a bigger picture stuff going on. There's climatic forcing, which is what you would expect with something like salinity. So it's driven by rainfall on the land, as well as the influx of the Atlantic water and the Channel water. That results in that high point at the end, 2025, one of the high salinity years in our time series. At the same stations, the Environment Agency take monthly measurements of all the water quality parameters. Now if we look at nitrate, one of the main drivers of phytoplankton productivity, there's less of that synchrony between the stations. So in that mix, there are 2 stations just outside of the south end of the East May region, sort of the Essex Estuaries complex, and they finish up by Bridlington, up at the north of our region. And the shading of the stations here, the lighter colours are the Yorkshire stations, and the darker colours, as we go down with latitude, are the more Essex stations. There is some synchrony in there, but if you look at the standard error on the nitrates over time, it's quite broad. It's quite a variable parameter. There's lots of things changing it. Some tendencies there at the end. The last 5 years, we're seeing lower nitrate concentrations on annual average. The values are actually quite low, and when we go out and do our own measurements, particularly in the summertime, it's below the limit of detection with the system we have for nitrates. It's actually very, very low. So they try and give this impression here that the North Sea is no longer a eutrophied system. The nutrient values, once you're outside of the estuaries where the values are still high, the actual coastal nitrate values are quite low, and they might be reflecting things that's going on the land side, might even be reflecting all of the monetary alignments and things like that, which probably are a big nitrogen sink, cleaning up the water. We looked at phosphate in East Bay last year, and that's a very clear signal that's going on. Downward trend for many, many years. Like many European estuaries, phosphate is being stripped out by sewage treatment work, so we no longer use phosphate in dishwashing tablets and in washing machine washing powder. So phosphate's been declining for quite a long time, and 2025 is actually one of the lower years in the phosphate time series. So this is quite strong evidence, quite good data, and there's some agreement, at least in the stations that are close together, in the anomalies. So the Yorkshire stations, as you might expect, all do the same thing with respect to phosphate. So again, it's heading into a low nutrient direction. And one thing that jumps out is when you take the 2 main nutrients for phytoplankton growth, N and P, that ratio is actually changing quite strongly over time. And that's got some quite important consequences. There's a lot of work being done in the Bay of the River Seine in France, looking where the NP ratio is also increasing, phosphate going down, nitrate actually increasing, driving changes in this ratio, and that has quite important effects on the phytoplankton. Potentially not in a good direction, so high NP ratios could favour some of the more nuisance algae and toxic species that we don't want, whereas maybe the more nutritious diatoms that we would want, they would be a lower NP ratio. That's really strong in the estuaries, which are, when we do our measurements, say up at the Humber Bridge, absolutely full of nitrate, not much phosphate, very high ratio. And the estuaries actually do a huge processing job as we go down. They're doing a really important job in removing some of that nitrate particularly, but you can still see the NP ratio changing in the coastal waters. So does that change something of importance when we think about the seabirds and the seals and the benthic life, all depending on productivity of the phytoplankton in the water. That's the main food source for the East May region. So that productivity, is it changing? Is the amount of food available for filter feeders changing over time, and for the worms and so on in the mud? Well, it depends what data you look at. It's actually quite hard to tell. I would say the jury's out at the minute. We need to do a lot of thinking about that. I'm presenting here the data actually from remote sensing from satellite for the years since 1997. The yellow line is 2025. Nothing particular stands out in last year in terms of biomass of phytoplankton. The peak is in May, as it is in most years. That's the later, slightly later spring bloom. It's much earlier in the northern North Sea. It's more March, April in the northern North Sea, but southern North Sea, the spring bloom is actually quite late. Satellite data, Environment Agency data is a bit noisier. The peak month is the same, it shows the same thing. The station data shows a high chlorophyll in May, and again 2025 fits in the end quite nicely. The EA data doesn't show as much of an uptick in the autumn, a sort of a late autumn bloom effect. We don't see that in the station data that we see in the satellite data, and you see some occasional very, very high values that we don't pick up in the satellite data. So different measuring methods giving slightly different stories, and I think it needs some work to work out what the long-term trends are. If we would expect changes eventually to happen due to the changes in the nutrient driver, and it's one to keep an eye on. And this, I think, if you look at it by eye, so this is the EA chlorophyll data over time for the coastal stations, those 9 coastal stations, and then for the stations inside the estuaries. I mean, I can see with my eye, I think when I go through that, there is a change in time. We're getting less of the higher chlorophyll values at the start of the time series in the mid-2000s up to about 2010, and it looks like chlorophyll is decreasing. There's a couple of years that stand out. 2021 was a very high bloom year. Depending on how you plotted it, it looks more of a spike, and potentially, like the nitrate and phosphate data, a bit of a decreasing trend through the middle of this decade. So it's going to be really interesting in future years to see where this trend continues over time. We've got then from Elizabeth's Plankton project at Cromer Pier, incredibly high resolution, weekly resolution, high accuracy phytoplankton and zooplankton data. So if you follow Elizabeth like I do on social media and see these just incredible videos and learning the names, learning from actually looking at some of the species that are there. We've started doing our own zooplankton work north of the Flamborough front, so hopefully by next year we'll have a full 12 months of actually complementary plankton data. So some of the things that stand out, in May, the big Phaeocystus bloom with what may be harmful algal species, Pseudonychia mixed in there as well. Some new records, most southerly record for this species of copepod in the samples there. All of these species and sea gooseberries that we've seen in the wash-up data, and medusae of various hydrozoans that we see also in our Humber zooplankton data when we look at certain times of year. We're seeing these in the springtime as well, and various other species in there as well. So we're starting to build up a picture of the dominant players in the phytoplankton. That gives an indication not just of the true phytoplankton, the copepods that live there all the time, but also those ones, those benthic animals that have a planktonic life form. So we might start, for example, if there was a change in the number of sea urchins, we would start to pick up echinoderm larvae in the zooplankton counts as well. So these are really, really valuable long-term records. So to finish off this section, water quality, looking at the biological side of water quality, and there's an opening. It would be, I've done now 3 EastMEs. It would be very nice if somebody next year could actually step up and do the chemical side, the PCBs, the heavy metals, and do that for EastME as a different angle. Next year, if somebody wants to join the COP and work through all of that really detailed Environment Agency data on the chemical side of what's happening, would be very interesting. We've got this drought year, which has driven up the coastal salinity, so think about that with species appearing. More maritime species versus more estuarine species might be favoured. These are changes in salinity of about 1 ppm, so they're quite big. They're quite significant changes in salinity over quite a large section of the coast. Nitrate and phosphate going down, the increasing ratio of the two, the NP ratio over time. The bloom peak, as it normally is, around about May. and chlorophyll, everything else round about average value, so nothing really jumps out. We didn't see any big summer blooms, anything unusual in the plankton. If somebody has other data, please get in touch so that we can record that when we write up the script of the meeting. Right, I've got a couple of minutes to do the oil tankers. 1 minute, right. So the big thing that did happen last year, and Sarah Craythorne has put some slides together which are going to be on the Easterby website with her voice recording over the slides. We had this. We had an oil tanker collision, which very nearly was an absolute disaster, and I think we escaped very, very lightly. So Lincolnshire Wildlife Trust in the thick of it, as well as many people trying to understand what's happening, going out and getting samples and so on, getting involved with the clean-up. So please look through the recording when it's put on. So the collision site was just off the Humber, just past Humber Gateway Wind Farm. Small coastal container ship rammed into a tanker carrying 100,000 tonnes of aviation-grade kerosene. One of the tanks exploded, the other 15 out of 16 tanks stayed intact and saved a major disaster. But what it did do is bring the community together, get a lot of people talking to each other, the IFCA's at the heart of it, and the wildlife trusts. I think everybody saw this on the news at the same time and dropped everything they were doing that week and tried to get samples organised, get out on boats, get things done, and try and understand what might happen. And originally we thought there was going to be cyanide in the containers of the ship, but thankfully that didn't happen. So messages from that. It was a very near miss. The worst case impacts were avoided. It brought out very good interactions and resilience, the local resilience forum. It showed actually institutionally how often you have to have different messages, in our case in the university, squaring off different lines of people, doing things that's something they've seen on the news and not realising that we were out trying to get samples, and you need good comms internally and between partners. It shows that we need to have the readiness as an Eastme unit. We need to have boats and equipment and people and citizen science to actually be able to go out and do things. If the worst comes to the worst and something like that happens again, you need to know your sites, so everybody has to come together. But certainly it stimulated us to upgrade our sampling kits, so we've got things like fuel detectors. We always keep clean bottles ready to take samples and things like that, so it really makes you think about how you do things. So that is my final slide. Thank you very much.